Hi there. In this video, we'll learn how to graph parabolas the easy way. But first, how do we do it the complex way or the hard way? Well, we start by finding the vertex, focus, the orientation, latus rectum, axis of symmetry, and the directrix. The advantage of this one though is that the graph becomes more accurate. To learn about this, you may check out this video from another channel, which I'll probably link somewhere around this video. So now, how about the easy way? Well, we need the vertex, and that's it. That's it? Yes? Okay, well, okay, maybe two more points, but you'll see later on that technically it's just the vertex that we need, not really any of these points. So without further ado, let's go on with our first example / illustration. So in here we have y equals x squared minus 2x plus 8. Let's start by obtaining its vertex. So what we'll do here is we'll apply the strategy that we showed in a previous video on how to get the vertex immediately from the standard form equation. So that is what we'll do is we'll write this one as 1 times x squared plus negative 2 times x plus 8. And we know that in the standard form equation, 1 out here refers to a, while negative 2 out here refers to b. So we can use this to obtain the vertex. Starting with h, this is equal to negative b over 2a. So this h is the x coordinate, take note of that. And so what we do here is we just plug in b and a. So we'll have negative times negative 2 times 2 over 2 times 1 rather. Then the 2's out here would divide. Negative times negative is positive, so we'll be left with 1. So we now have h, or the x coordinate for our vertex. Next, we obtain k, the y coordinate. We obtain this by taking note of the x coordinate h, so 1 out here, and plugging it into our equation. So that is, we'll have 1 squared minus 2 times 1 plus 8. This simplifies to 1 minus 2 plus 8, or is equal to 7. So we have k to be 7. And so we now have our vertex to be the point 1, 7. So let's now clear out some space and let's understand how would we obtain the next 2 points that we need. Well, take note that the parabola of this form is a parabola that is vertical, so either oriented like this or like this, but we know that it is oriented positively. And we know that the vertex is the point wherein we will have a change in the behavior of the graph. So from the left of it goes down out here, but upon reaching the vertex, it suddenly goes up. That's why what we'll do is we'll obtain a point from the left of the vertex as well as the right of the vertex to understand the behavior on the left and the right, since these two are the crucial parts. So again, vertex is like the shift in the behavior of the graph. So in this vertex out here, we can use the points with x coordinate 0 and 2, since 0 and 2 is 0 is on the left of 1 and 2 is on the right of 1. And let's obtain the y coordinates for these points. So that is at x equals 0. So plugging this one in this equation, we'll have y equals 0 squared minus 2 times 0 plus 8. The zeros out here will just cancel and we'll be left with 8. Similarly, at x, take note that there. So we have the 0.08 out here. Next, at x equals 2, we'll have here y equals 2 squared minus 2 times 2 plus 8. This is equal to 4 minus 4 plus 8, Or when simplified, take note that 4 minus 4 is 0, so we'll be left with 8. So we now have the point 2, 8. And so we now have 3 points for our parabola. So we can use this now to graph the parabola. So clearing out some space, clearing this one, move this, this, and this. And so let's have a graph out here. So how do we do this given this 3 points? What we do is we simply plot these points, all these points. So we'll have first the vertex at 0.17, the second point, which is the 0.08, so out here, and the 0.28. After this, we just connect these 3 points in such a way that it would look something like a parabola. So just like this. And so this out here is the graph of the given equation. So as you can see, it's very straightforward. Just get the vertex, get 2 points, one from the left and one from the right of vertex, and then plot these points, connect it with the line. The problem is that it's not really super accurate, but at least we have a kind of accurate representation of how the graph looks like and as well as how it behaves. So let's now move on to the next example. We have y equals negative x squared minus 4x minus 1. In here, you may pause the video so that you may try this one first on your own, since by this time you already have an idea on how to graph parabolas. Okay, good, so let's start. Again, we start by obtaining the vertex. So again, we can express this equation of the form negative 1 times x squared plus negative 4 times x minus 1. And in the standard form equation, we know that negative 1 out here refers to a, while negative 4 out here refers to b. So we use this to obtain the vertex. Starting with h, this is equal to negative b over 2a. So plugging in b and a, we'll have negative times negative 4 over 2 times negative 1. 4 divided by 2 will be 2. We can divide the negatives out here, so we'll be left with negative 2. So that will serve as our h. Next, for the k, again, we just use the value of h, which is negative 2 out here, and plug it in to our equation. So we'll have negative times negative 2 squared minus 4 times negative 2 minus 1. This is equal to negative 4 plus 8 minus 1, or when simplified, this is 3. So we have k to be equal to 3. So we now have the y coordinate for our vertex. So we now obtain the vertex of the parabola, so clearing out some space. What we do next again is obtain a point from its left and from its right. So from its left, we can use negative 3, the x coordinate negative 3, and from the right, we can use negative 1. So at x equals negative 3, we have y equals negative times negative 3 squared minus 4 times negative 3 minus 1. This is equal to negative 9 plus 12 minus 1, or when simplified is 2. So we now have the point, or y, to be equal to 2, and the point negative 3, 2. So we now have our second point. For the last point, at x equals negative 1, y will be negative times negative 1 squared minus 4 times negative 1 minus 1. This is equal to negative 1 plus 4 minus 1, or when simplified is 2. So we have y to be 2 when x is equal to negative 1. So our third point is given by negative 1, 2. So we now have 3 points for our parabola. We can now graph this one. So clear this out, like that. Then clear out the hk out here, like that. Then move this, this, and this. And let's have a graph out here. Again, given these 3 points, we just plot them up. Starting with the vertex at the point negative 2, 3. Then the point negative 3, 2. And lastly, the point negative 1, 2. From this, we just connect these 3 points. So we'll have this. Again, it's not that perfect, but this is a good representation of the parabola already. If you want to see the accurate version of the parabola, or its graph rather, you may try to use some graphing calculators like Desmos or Algebra. Those two are the most famous ones. And so this out here is the graph of our parabola negative x squared minus 4x minus 1. So I hope you got that one correctly, and I hope you enjoyed and learned from this video. To formally end this, here's an exercise that you can try to work on. We have x equals 2y squared minus 12y plus 7. I put this out here since this one is kind of tricky, since this one is a parabola that is oriented horizontally. So a while ago, the reason that we choose 2 points from the left and the right of the vertex, because we know that the parabola that we had in our examples are oriented vertically, but this time it is oriented horizontally. So how would you choose the 2 points that goes along with our vertex in this case? So that's something that is nice to think about, and you may comment down below if you have an idea on how we will obtain these 2 points from the vertex. In this case, that it is oriented horizontally. And you may also share your solution and answer to this one, but we can't really share graphs, I guess, in the comment section down below. So yeah, that's it. I hope you enjoyed and learned a lot from this video.